Here we go with another unedited, spontaneous video from your wonderful math teacher, Mrs. Taylor, this time on the binomial theorem. In class, we multiplied out a series of binomials called expanding a binomial. And so we're going to start with the simplest case, a plus b to the 0. A plus b to the 0 is just 1. So the top of our little triangle on the notes is just 1. A plus b to the first is a plus b. A plus b squared, you may recall, is a squared plus 2ab plus b squared. You get that by multiplying out a plus b times a plus b. A plus b cubed turns out to be this. So let's say we take a plus b times a plus b, which is a squared times plus 2ab plus b squared, and we multiply that by a plus b. Well, when I do that, I'm going to erase this so I have a little more room. When I do that, I have to distribute the a times each of these terms, and I have to distribute the b times, oops, I didn't mean to erase, and then I have to distribute b times everything as well. So I end up with a cubed plus 2a squared b plus ab squared when I multiply everything times a. When I multiply everything times b, I end up with a squared b plus 2ab squared plus b cubed. And I like to write it one step under the other and line up like terms, so then it's really easy to combine like terms. A squared plus 3, or a cubed plus 3a squared b plus 3ab squared plus b cubed, which is what I have in line 3. If I did the same thing with taking this result and multiplying it by a plus b again, I would end up with a fourth line and so forth. And I'm not going to go through all that multiplication, but suffice it to say then we end up with a to the fourth plus 4a cubed b plus 6a squared b plus 4ab cubed plus b to the fourth. Now, you may recall some patterns here that are starting to look familiar. I want you to see the patterns. Notice that as we go down the left-hand column or left-hand diagonal here, that the first term is a raised to whatever power I have over here. So a plus b, a squared, a cubed, a to the fourth is what I start with. Notice I end with b raised to that power that's up over here on the left-hand column. In between, notice that the a exponents decrease while the b exponents increase. So I start with a to the cube, b to the 0, so there's really no b there. A squared, b to the first, a, b to the second, b cubed. So I'm moving up with the b's and down with the a's. Up with the b's, down with the a's. There's a little interjection of humor for those who are bored right now. Now, there's also a pattern with the coefficients, and I'm going to add some coefficients in here in front of the ones that don't have them, and just remind you that there's a 1 every place here. 1, 1, and there's a 1 over here on the left-hand column. So if we look at just the coefficients and pull them out, we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Some of you might recognize this as Pascal's triangle. And the way you get each number from the previous number is by adding the two numbers that are diagonally above it. So for example, 4 is 1 plus 3. 6 is 3 plus 3. 3 is 2 plus 1, and so forth. So doing that same process, this is going to allow us to figure out what the next line is. So the next line is a plus b to the fifth. I don't really have any good way of doing this one, so I'm just going to expose it. A plus b to the fifth. Notice that we start out with a to the fifth, then a to the fourth, a to the third, and so forth, counting down. The b's count up, b to the 0, b to the first, b squared, and so forth up to b to the fifth. Notice that there's this, when this is raised to the fifth power, there's actually 6 terms because you start out with 5 and you end up with 0 for each of the variables, or start out with 0 and end up with 5. So you're going from 0 to 5 or 5 to 0, so there's 6 terms. Then notice where the 5 and the 10s come from. 5 is 1 plus 4. 10 is 4 plus 6. 10, this 10, 4 plus 6 plus 4. 5, 4 plus 1, and then there's a 1 at the end. So stop the video, see if you can fill out row 6 all by yourself. If you already know what it was, I'm going to go ahead and uncover it now. But if you want to pause and do it before I do it, pause now. Okay, back. Here we go. Oh, I forgot I hadn't written it down anyway. Surprise, surprise. Okay, I'll write it down. So we start out with a to the 6th. Then we have a 1 plus a 5, so plus 6. Hey, there's another interesting pattern. Notice the 2, 3, 4, 5, 6 matches the 2, 3, 4, 5, 6 here. So the second term and the second to the last term will always have a coefficient that matches this exponent. So 6a to the 5th b plus, well, 5 plus 10 is 15. 15a to the 7th b cubed. No, not a to the 7th b cubed. What am I doing? A to the 4th b squared. Hey, another pattern I want to point out. Notice that the exponents always add up to 6 here. 6, 5 and 1, 4 and 2. Another pattern. Lots of cool patterns here. I love patterns. Plus 20a to the 3rd, b to the 3rd, plus 15a squared b to the 4th, plus 6b to the, a b to the 5th, a b to the 5th, plus b to the 6th. So let me make sure I didn't make any mistakes. 1, 6, 15, 20, 15, 6, 1. A's are counting down, B's are counting up. I'm good. Now, because we have a pattern here, we can create a rule that establishes the pattern, which we're going to do with sigma notation later. Ooh, cool, cool. But right now, I just want to say, let's multiply out something by hand and then see how much easier it is to do it with a binomial formula. And you're thinking, that's a stupid thing to do. Why don't we just go straight to the formula? Well, I want to justify to you that the formula really works. So we're going to multiply out 3x plus 4 to the 4th power. I'm sorry, 3x plus 5 to the 4th power. Dyslexia of the tongue there. 3x plus 5 times 3x plus 5 times 3x plus 5 times 3x plus 5. If you haven't multiplied out a lot of binomials or expanded a binomial in a while, realize that you should do it in pairs. You don't try to do it all at once. You multiply a pair, those two together, those two together. So that gives me 9x squared, and my last term is 25, and my middle term would be 15x plus 15x. So anytime you do 3x plus something squared, you just square the first term, you square the last term, and you multiply the first and the last and double it to get the middle term. That's your 2ab. Anyway, do that twice. Then you're going to have to distribute. And I'm going to show you how I do it to keep it organized and make it look nice. And I think I'm going to shut this thing now and extend the page so I can bring this up a little bit. Okay, there we go. So I've got 9x squared plus 30x plus 25 times itself. So I'm going to start with multiplying 9x squared times everything in the second trinomial here. So that gives me the 81x to the 4th plus 270x cubed plus 225x squared. Then I'm going to multiply 30x times everything in the second trinomial, which gives me all the red terms. Then I'm going to multiply 25 times everything here, which gives me all the black terms. Notice that I've lined them up. The reason I like to write it this way is then I line up my like terms, and it makes it easier, first of all, not to forget a term, because there's 9 terms altogether. It's really easy if you write them all in one big line to only do 8 and just accidentally leave one out. Also, it makes it a lot easier to add them up at the end. So here is my expanded binomial. 81x to the 4th, and so forth. I don't need to read it to you. You can see it. Okay, that's why this is a video. Now, we are going to next look at how do we do the same thing but using the binomial theorem to simplify this process and make it not quite so tedious. So flip over to the other side of your notes. Using the pattern of coefficients and variables you found by multiplying and using Pascal's triangle, expand 3x plus 5 to the 4th. So first of all, I have to recognize that this is in the form a plus b to the 4th. And a plus b to the 4th, if you go back and look at your Pascal's triangle, would be a to the 4th plus 4a cubed b plus, and let's flip back and just double check this. What's the next term? Oops, how would I remember that it's 6 next? Here's what I do. Sometimes I think, okay, let's remember Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I can remember those. And I know I want this row because it has the 4 in it in the second position. So I know I'm going to have 5 terms, and there's my coefficients. So I say 6a squared b squared plus 4ab cubed plus b to the 4th. Now this becomes a pattern for me. I know where all the a's and b's go, so what do I do with the 3x and the 5? Well, 3x is my a, and 5 is my b. So every place there's an a, I put in 3x. Every place there's a b, I put in 5. And I just use this pattern right here. So I'm going to say 3x to the 4th plus 4 times 3x cubed times 5 plus 6 times 3x squared times 5 squared plus 4 times 3x times 5 cubed, a little lag there, plus 5 to the 4th. Come on, there we go, got it. All right, slow computer today. Then all I have to do is apply the exponents to what's inside. So 3x to the 4th is 81x to the 4th. You think, how do I know that? Because I'm brilliant. 3 to the 3rd is 27. 27 times 4 times 5, that's a little maybe, I think that turns out to be 540. Let me look at my notes. That would be good. Yes, indeed, 540x cubed plus, then I have 6 times 3 squared. 6 times 9 is 54 times 25. Ooh, 54 times 25. That's the same as, I'm not sure off the top of my head, but that's 1350. How about that? We'll go with that. 1350x squared. You might want a calculator for some of this stuff. 4 times 3 times 5 cubed would be 12 times 125. That's 1500. And you just have one x there. And then 5 to the 4th, I know what that one. That's 625. Because that's 25 squared. Okay, did that match what we got before? Yes, it did. And was that a little easier? Yes, it was. Because there's fewer steps, fewer chances for careless mistakes. So what do I want to see when you do this work? I don't want to just see the answer. I want to see the numbers plugged into this right here. Now, if you want to do additional work in between these two steps, feel free. If you just want to use your calculator to get your coefficients, good. Remember that the exponent, remember to use parentheses around your terms because anything in the parentheses, that exponent applies to everything in the parenthesis. So if you do not, or in the parentheses, I should say. So if you forget to put parentheses, you might think it's just 3x to the 4th instead of 81x to the 4th. So be careful about that. Okay, let's look at this one. This is to the 6th power. So my template that I'm going to be using, I think I'll add a couple more rows to my Pascal's triangle up here. This would be 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So I'm going to be using this last row and starting with a to the 6th. So I'm going to use a to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b to the 4th plus 6a b to the 5th plus b to the 6th. And that's crowded. You realize when you start putting in other things for A and B that you'll probably run out of paper, so start way over to the left edge and write small, and I will try to do the same thing. Okay, in this case, this is a little trickier because in this case our A is equal to 2x cubed and our B is equal to, get this, negative y. Ooh, which means we're going to have alternating signs in our final result because if negative y is raised to an odd power, it's going to stay negative. Okay, so let's start plugging things in. I'll do this in blue just to make it different. So I'm going to have 2x cubed to the 6th plus 6, oh, I need to move that plus over. Got to save space. Plus 2x cubed to the 5th times negative y. So this term is going to be negative because it's a positive times a negative. Plus 15. Oh, I forgot the 6 on that term. Oh, my word. Half point opportunity missed again. 6 times 2x cubed to the 5th times negative y plus 15 times 2x cubed. And you know what? I'm going to pause the video and finish writing this so you don't have to sit and watch me write this, because you can write this down yourself. So let me just pause the video right now, and I'll come back having it written. Okay, I'm back. Notice I've written this all out. If you need to pause this and check your work, that might be a good idea. Hopefully I probably should check my work. I believe everything's correct on here. Multiplying this out's a little tricky, so you'll also want to maybe try that and check your work here. Notice when you get to the end on this one that you're doing 2x to the third to the 6th, which means you're going to have 2 to the 6th, x to the third to the 6th, which gives you x to the 18th. So even though this is raised to the 6th, this binomial is raised to the 6th power, since there's an exponent inside the binomial, I don't end up with 6, 5, 4, 3, 2, 1 for my exponents. I end up with 18, 15, 12, 9, 6, 3, because they go down by 3s because it's an x to the third in there. Notice also the alternating sign, positive, negative, because whenever x or whenever negative y is raised to an odd power, it makes the sign negative. Whenever it's raised to an even power, it makes the sign positive. So if you need to pause and look at that some more, go right ahead, but I'm going to move on. Actually, no, I think I'm going to stop here and we'll go to a part B for this, because these notes will get a little bit too involved otherwise. We're already at 17 minutes, so I'm going to stop here and do a part B for the rest of the notes.